Do you guys need to stand up after all this discussion of physical activity? Everybody stand up. Yeah. All right. Well, I try and figure this out. I'm buying time here. So I'm really thrilled to be here. Thank you, Kevin. Thank you, all the organizers, for inviting me. Feel free to stay standing. If you want to stay standing, just go to the side so that you're not standing in front of people. I get to do the fun thing. But before I do the fun thing, here's my disclaimer slide. My work isn't really my work. It takes a village to do mobile health and new technologies, and these are some of the most important members of my village. My funders, needless to say, the M2 Fed team I'll be talking about later, multi-scale computational modeling teams that includes Eric, who's here, the repository for the radar team that includes James McLean, who's not here, my mHealth Collaboratory Institute Institute of Creative Technology team, and the Imagine Health team. So this is just some of the people that I work with, but I want to thank them all so much for their work with me. Okay, so regroup. What have we heard? We've heard that the Internet of Things, or all of these connected things that we use that are forever streaming and capturing, are giving us this huge, huge new data. And it's time to sort of rethink what we do with that. So this data can be breathtakingly fast or incredibly slow, right? It ranges. And it can also be breathtakingly precise or incredibly dirty, right? Here's where I'm going to use my notes so that I remember to say all the things I wanted to say about this slide. I never knew to use notes because I can't see. But the thing about this is these data can be, it's an exciting opportunity because these data can be used and fused to give us new indices. They are allowing us to ask new questions that we've never asked before because of the kind of data that we're getting now. I think it's really important to think about also, do we have ground truth? Some of our sensed measures are not the same as the measures that we're trying to replicate, and some of our sensed measures might be better. So I'm going to read you this because it's so great, and this example is from Wendy Nilsson. For example, what should your blood pressure be when you're stuck in traffic and late to pick up your kid? Maybe it's totally normal to be 180/100, but maybe not. And is diastolic blood pressure really the best measure for that? Maybe continuous measurement of some other parameter better reflects health and the long-term risk. But do we need 20-year outcome study to figure that one out? Right? What does precision or accuracy actually mean in this new context that we're living in? So I feel like, whereas technology measures are usually objective, legacy measures, for instance, in psychology are usually psychology and psychiatry are usually subjective. So this objectivity of technology measures makes them apparently unbiased relative to subjective self-report. But on the other hand, tech measures are also less familiar and comfortable related to trusted legacy measures. So trust in the measure, even if it's less accurate, is giving us a big pain in the Buddha kister. Right? So what if we had a really accurate measure of heart rate, a certain rhythm in your heart that was a better predictor of suicide or depression than a questionnaire? We'd use it, right? And we'd try to figure out how it related to the old legacy measures, and then maybe we'd drop them, only use them when we need to use them. Okay, so that was all of my notes. No, it wasn't. Yes, it is. So we need to use this data to really enrich the way that we're thinking about our research questions. Because here's what I want to do with it, to preface what I want to do with this data, is I want to do just-in-time adaptive interventions. I am an intervener at heart. I have a writing reflex as big as the state of Hawaii. I want to make change for good. So just-in-time adaptive interventions, otherwise known as JEDIs, therefore, they're adaptive. In other words, they change with your needs, so that I'm not forever giving you, what if your goal is 500 steps and you start meeting your goal and I'm still sending you messages about 500 steps. We need to change the thing. They're personalized to what you need. They're delivered via mobile devices. They can be delivered anytime, anywhere, and when the person is in need or vulnerable and receptive. And they are more effective, and they are more effective than standard interventions or simple reminders. This is a recently been shown by Josh Smythe in a really cunning research. So, and they're responsive to moment-by-moment context. So this is a bar in Iceland where a bunch of children were dancing in and out, but somehow they're not in this picture. But because context is really king. So where and when we do behavior is king. It makes all the difference. So my worry right now is where we are right now is maybe we're a little bit stuck in the past. Maybe we aren't asking the right questions. So that's what I'd like to do with this session, is to see if we can't regroup a little bit. What do we really need to know? Case of physical activity. So this is the radar or repository for algorithm development and ambulatory research radar team that James McLean led out of NCI. Actually, John Locke and I led it, and it was James McLean spearheaded it. And we had this mission as a radar work group to develop preliminary recommendations for information and infrastructure resources needed to support and enhance health-related body sensor networks research to measure physical activity. So in other words, how are we going to use all this new stuff to measure physical activity? Kevin was a part of this also. Our primary questions were, what kind of information, what do we need to know to really measure physical activity accurately so that we can answer these new questions about physical activity? And the answer is, with this incredibly illustrious group of people, we couldn't agree. Remember that big data elephant? Everybody had their hand on a different place, right? Do we need to know, is steps enough? Do we need dynamic acceleration? Bouts, intensity, sedentary time, sleep, psychosocial data? I vote for that. Activity identification, which is what you were just talking about. Do we need that? Is it useful? When is it useful? Is it a rabbit hole? What about context? Social context, environmental context, ambient light, cardiovascular fitness, maybe that. Energy expenditure, calorie, you get the idea. I'm not going to read the whole slide to you, but I could. So we weren't sure what we really wanted to know, and this was top physical activity researchers, right? So I think one of the things that we have going on right now is this kind of interesting false dichotomy. It used to be, and I still think it's important because I also do lab research, there's lab and field. But as we get closer and closer to this Internet of Things, it's going to become a false dichotomy. And I think that we really need to work towards that. So what Job, you guys were showing us your measurement stuff, the fantastic lab upstairs. And you can have sturdier, bigger things in a lab than you can out in the field. But I really do feel that as we start asking the right questions and get more cunning about the things that we make, that we can end this really difficult dichotomy, which takes us a lot more time to do the work, right? Okay, so here's the thing with the data that we're getting. We have this continua in digital data. It's a multi-level, multi-dimensional problem because all this data that you're getting that's coming into you in any study is different on all these continua. So there's the nature of the measure. Is it direct on this side or indirect on this side? How about the inference? Is it objective or are you imputing this measure? How frequent? Is it really infrequent, like 3-day dietary recalls or doubly labeled water at the beginning of a study and then never again, or at the end? Or is it continuous, like accelerometry? Is it precise? Is it accurate? Some of our measures, some of these sensor measures are so accurate. Or is it, I won't name any names, really inaccurate and incredibly messy, but still signal? I wanted to draw this for you as how these all work together on but it's 4 dimensions, and so I need you to help me think outside the tesseract. Yeah. So what should we do with this data? I think that we need to start mashing it up and dynamically modeling this digital data. I don't know that we need new theories. I think we need new computational models because we can model behavior. So there's all sorts of different ways of thinking about modeling this data. And you've heard about some of these today. I think that if we have all this incredible data and we can think with an open mind, we can ask new questions of this data, but it's going to take transdisciplinary teams. If we do this, we can ask really semantically interesting patterns of behavior, questions about patterns of behavior in health, instead of just what's going on right now. We can get new variables and indices that can be discovered through this mashup of measures. These can be adjustable across dimensions. They have to be, our measures have to stop being static things. They've got to be adjustable across dimensions so that there's a probability of a particular state, and it's personalizable, and as time-sensitive new data comes in, it changes with you. So this is a state-space thing that Eric was talking about earlier. And it's going to give you these new computational models of behavior. So I've made one up for you. So let's say that on top you've got this new variable. So let's take the axes first. So on one axis is maybe a mashup of cognitive and emotional. It's a composite of, it's very frequent, ubiquitous, and periodic self-prompted measures, related measures, and you've mashed them up in some way that you and your engineer friends have sat there like mechanics over a car and dug through these signals until you found something that seems interesting, right? And then there's a behavioral variable or a syndrome or a composite. It's also got a mashup of different levels of data, and that change on different time frames, right? So my stress levels go up and down like a rabbit, but my self-efficacy goes up very slowly during an intervention. And how do we capture these and make these into one index that can be helpful, right? And then there's a physiological variable of syndrome that's a composite of this very expensive data that you can take every once in a while, and this very cheap data that you can get on a sensor that doesn't cost much. And there are also different time frames, different validities, different accuracies. And together, if you can mash those up and you get this new variable that's valuable, ongoingly estimatable, sensitive to meaningful individual changes, and modifiable at several levels. So I'm making it up as I go here, but I think this is where we can go. I think it's where we need to go. We need to think about what new transdisciplinary questions we can ask this data, and how we don't have this temporally dense data at every level, but we have to think across time scales. We have to make use of this temporal mismatch. We can actually, instead of thinking of it as the devil, think of it as a useful variable. We can enhance the classic description of past with prediction of the future based on specific priors that we can feed into these models in an ongoing fashion. What we need to ask ourselves again and again and again is, what's the signal in the current noise that we can use? And search this way for new, meaningful mechanisms, okay? So this started with physical activity. I'm moving to diet, all right? I'm going to get more specific now. And this is M2 Fed, a project that with my colleagues, Jack, John, and Kayla, monitoring and modeling family eating dynamics, M2 Fed. It started as M4 Fed, modeling, monitoring, modifying, and maintaining family eating dynamics. And NSF sent it back to us and said, really, in 4 years? Probably not. Send us 2 of the M's. We'll take 2 M's at a time. Thank you very much. And they were so right. So anyway, here's what we bit off. The motivation is that the wicked problem in obesity research is accurate measurement of what and how much people eat outside of a laboratory situation, as David earlier said to us. We have no friggin' idea, pardon my language, of the energy intake. We just don't. And Carol, one of these days, maybe you have an idea of what people eat a lot of the time. But what, energy intake? Is that the question we should be asking? I'm not sure. What is the question? So do we need if we need a mechanistic understanding of nutrient effects on health, then we probably need an in-lab study of exactly what people are eating, or in-hospital studies, some of the stuff that you do and that David Ludwig does, that I've done, just capture these people in my lab and make them stay there for all day. But if it's interventions, maybe the questions should be different. So here's another thing. I don't know how much time I have to tell you long stories, but we've found, certainly working with kids, that messages about modifying nutrient intake how do those public service announcements work for you? Not so much. They do not work so much. And one of the reasons they don't work is because we as nutritionists keep changing our mind. what's good for me again? Reduced fat. Somebody said reduced fat. I'm supposed to reduce fat, but maybe it's sugar. That's what we're finding. It's not the fat, it's the sugar. It changes all the time. It's really hard to get behavior change on the based on an intervention that tries to get people to change their nutrients, and we don't see the behavior maintained. However, and Leslie, I can't believe it, Leslie Lytle's here, my muse. Family eating dynamics have a major influence on eating behaviors, and we can change them. We just can't measure them yet. So that's what FED is all about. So M2 FED is all about developing these models of family eating dynamics. So what we want to know is speed of eating, and if the kids are all, if the family's at home, so in the home, is how fast I eat. Does that influence how fast my daughter eats? How about if I'm happy during an eating event, or sad, or alone, or it's Monday night, or it's Sunday night? You know, does that change, and how does my mood influence mood of somebody else in the household, and how does that influence their eating behavior, right? So here's our a little mock-up family dynamic model. This is a networks modeling done by Kayla De La Haye, where you see that if adult one is stressful, it's going to influence, for instance, does this have a pointy thing? Yeah. Influence, for instance, adult one stressed out. Child one comes home, and adult one, that stress influences child one's stress. That goes up a little bit, which then influences adult one's stress, which then makes adult one angry, and then this makes child one eat faster. I mean, this is made up. We don't have the data yet, but this is what we're looking at, right? Doesn't that sound like fun? I love my work. Dang. And then we're going to make these system dynamics models of family eating dynamics. So here's the transdisciplinary challenge. How do we measure this stuff unobtrusively? Model dynamically in real time in people's homes, like in the real world. So we're developing this system of systems, like it's a cyber-physical system, really. That's what Jack Stankovic does, to monitor, measure, and model FED in real time in homes with overweight parents and children. We really hope by using this, it's going to be a smart home system. We hope that by developing this, you can use it to intervene on childhood obesity using this dynamic family systems approach. Everybody's talked about how important the family is for kids. I'm not going to go there now because, time, but that's really important, and that importance changes as they get older. It goes down, right? So that's a thing that we know, and we need to know how that really works in real time. It is the thing that we just thought we knew. I'm interested to find out. So this system that we're developing, this system of system, can provide a framework to determine the most appropriate nudges for a given individual in a given situation. So this is M1 and M2, monitor and model, and then, but the system is going to be built to do M3, and that'll be the next phase, so that we'll know where to nudge, where the bending points are, right? And it's going to be able to deliver these JEDIs, just-in-time adaptive interventions. Very exciting. So here's no engineering talk would be complete without this diagram. So here it is, my diagram. So, the cloud, the acoustics, there's microphones, and people are wearing watches on their dominant wrists and using phones. We've got beacons spread throughout the house, just a few, but and I'll tell you what we're measuring. Eating speed, which was talked about earlier, when people eat, the length of an eating event via smartwatch. Location, we'll know who is in the room, what room you're in. We also know through these beacons who's in the kitchen and who's opening the cabinets in the refrigerator. We don't care what they take out. I just want to know about the events, right? Speaker identification, this turned out to be a tough one, using sound. So we're using ambient sound, no words, because then IRB, and what a horrible feeling. You're actually, so we're not doing that. Just speaker identification, so who's speaking and what's their mood. Are they stressed? Via voice sound trace. And sensed event and time frame triggered ecological momentary assessment for eating in the absence of hunger. So if somebody eats, we know that they're eating, then X minutes later, if we are still figuring out exactly when, we will then say, we see that you just eat, or we thought you just ate. Were you just eating? And if so, how hungry were you before you started? And how full are you now? It's a little bit retrospective. We also have some random prompts for hunger. So sensed and random, and also sensed and random prompts for mood. How are you doing that, you might ask me? Right now we're in the lab doing protocols for algorithm development using these family discussions on eating behavior. So we bring them in and we give them a checklist to talk about, of food, what would you, anything you'd like to see differently to your family. I can give you the protocol. Never thought it would work. People get into it. Would you like to see your family eat differently? Mom, I really hate the lasagna that you make every Friday night. They get into it. So we get a range of emotions, and then we code this. Brooke is here. Hello, Brooke. Raise your hand. Thank you very much. She's coding all these tapes, and with another woman in the lab, and we send it to the engineers. And we also have an eating protocol for eating and drinking detection that is, and it's going to be augmented with smoking, because they might be smoking, but we have to go to a different lab for that. Can't smoke in my lab. And the idea is once we get these algorithms up and running, they're pretty much up and running now, we will implement in homes and do an observation piece to make sure they're still running in the homes. And then we're just going to let them loose, and hopefully people will use it for about a month. So we're going to have some really interesting data. Let's talk about data. So I am really excited about what Jack's lab has done, because we're all different disciplines that want to access this data. I'm a social scientist. I still use SAS and SPSS. Kayla Delahai is systems network. She uses a different program. Jack and the engineers use support vector machines, machine learning, and one other thing that you already mentioned. That thing. And a bunch of, and so we all need to be able to see this data. We need to be able to touch the elephant in our own ways. So this is the cloud. It's on the Amazon cloud, actually, most secure place on earth, turns out. And they've made this wonderful template for it, so we can visualize and we can download data. And this is, I'm showing you the social scientist views. So you see up here, this is variations in mood and time, stress levels throughout the day, duration of meals, and then you can see, you can put people together, you can see breakfast, lunch, dinner, snack. I don't know, the engineers think that's really important, but maybe just how long, just when you're eating is important. Maybe it's not so important. I'm curious now. Huh? Yeah, exactly. So, but we are making it. We're not asking them. I don't know if it's, I don't know. I think you're right. And that's one less thing to worry about. But, and then this is who they're with, and phone usage. We're also scraping their phone usage during the day, and at mealtime in particular, and a whole bunch of other stuff. So any questions, oh yeah, we'll ask questions later. So I have one other thing I want to say. So it's really cool. I'm excited about M2Fed. But I've spent a lot of time working with kids, and I just wanted to impart a couple of lessons from working with digital natives. All these worries that we have, the ethical worries, I'm an ethicist, so I get to tease Camilla a little bit. They're not their worries. They have different worries. And it's going to change all the time. This research will never be done. We have to keep querying our kids that we work with, what's important to them, what they're willing to wear. But this digital stuff blends seamlessly into their experience, so it's okay to ask them a number of questions on EMA. However, it better be good, because they're used to seeing really slick stuff. When we did a just-in-time intervention with kids, and they contacted us 14 to 18 times a day on their own, because we would talk back to them. And Cheng Wen, where are you, did all of that really good work. Yeah, there you are. One of them said at the end of the study, it's like having a doctor in your pocket. They loved it, right? But it better be accurate. You better be right. So we were asking, we were saying, hey, I see you've been inactive for the last 30 minutes, because we were classifying at the time. And, you better be right with the kid, because if you're not right, they're done with you. Oh, this is stupid. So accuracy is really important, and it's got to be personal and engaging, but watch your language, because we are not them. We will never be them. And this is Susan Wilford's really, I think, fantastic article. OMG, do not say LOL. Obese adolescents really don't like you to try and use their language. Are they willing to share? So here's another thing about data sharing. When I ask kids, are you willing to share your data and your digital traces that Eric was talking about with researchers like me? Yeah. Are you willing to share some of that data, even if it's only your physical activity, with your family? Hells no. So this is also a different situation, something to think about. Privacy and security concerns are different than ours. These kids are the future. They have much to teach us. So, implications. Thinking outside the Tesseract. I need all of your help. We need new mindsets, I think. What can we know? What questions should we be asking? What new variables are waiting for us to find them? How can we mash up this great data and this less great data that is at different frequencies of collections, ubiquitous versus self-report, changing at different rates? How do we mash this up and make new indices? How do we really use this data? We need new computational learning models of individual behavior. So I don't think there's going to be one theory that fits all. I think there's going to be one mechanism to develop to use the data that fits all way down the line. But we have to figure it out. I think we have to think on an individual dynamic level. We have to share our algorithms, but a problem with that is that we need ontologies, as Eric said. Eric and I found out that we ended our talks in exactly the same way, on exactly the same paper, is that we need, well, yeah, we did write that together. We need ontologies, as certainly in the behavioral world, but also in the physical activity world. What's a thing, and how am I going to share my thing with you? Because as we collect this incredibly valuable data, we need to be able to share it out. That means annotations, algorithms, the whole banana. Anyway, this was so much fun to prepare, and thank you so much for listening. You guys must be all falling asleep. I just stay connected in this crazy digital world. Thank you very much.